Okay, so welcome to the second part of the tutorial. By this time, I think starting from the morning session of Vikash and then Chilaya, and now with this third part of these different talks on fashion, style, etc. So we are a bit confused about how to differentiate, and when we say we want to recommend something, what do we really recommend? We recommend a style or a fashion. It's a bit confusing. I mean, it's a lot confusing, not a bit confusing. And so I was trying to, while preparing the slides for this tutorial, I was trying to read up some material. Okay, and suddenly, while going through the newspaper a few days back, so I came up with this, call it news or reporting, okay. So it talks about Charles Dickens, and of course he lived 200 years back, and life was simple. So he had this kind of interesting dresses, but of course those were colored dresses, but at that time the color photography was not discovered. So whatever photos were there, all were like this, and based on whatever information people had about him, and some people had written in some letters or some notes that he had visited some the king, and then this is the kind of outfit he wore, these are the colors, and from there they tried to render and ended up in a dress like this, so which you can see that it's a red kind of jacket with some floral prints with yellow and blue and all that. So life was simple in those times, no color photography, you can wear those kinds of dresses and still carry yourself on. But life is not so easy now with Flipkart, where you have to buy online and then you have to ensure that you get good recommendations, whether it is dress or it's book or movie or whatever. So we are in the age of recommender systems. So we also would like to have some nice recommendations, okay? But recommendations on what? Okay, so we have to see what would be a good working definition of what we are trying to recommend. Okay, so is it really fashion is something that you recommend, or style, or what? So if you remember some of the slides that he showed about how to define and differentiate between recommendation and style, one famous quote is that fashion fades, style is eternal. So it's all about style, means you have a certain style. So we'll say that it is his style, right? Obama had a style. So it says that Obama had only a few suits from which he would choose to wear every day, but he had a style. So people say that he had a style of wearing or carrying himself. Okay. So in the literature, of course, that now that life is not simple, we have Flipkart and Amazon and others, and also life is more difficult because we have deep learning and CNN and Siamese and all sorts of stuff, and we diehard researchers and faculty members, we try to jump onto the bandwagon so that we can apply this into that and this into something else, so you get some good papers. So people have also done similar things, that when they talk about in the papers that what is this paper talking about, so they have their own definition that suits basically the way they would like to apply their solutions. Okay, so we'll try to see some of those. So there is hardly any general consensus. If we go through the papers in this field, it's very difficult to say what is meant by fashion recommendation. Okay, so people have different ways of defining. Sometimes something that way they define is what suits them. Okay, so there are various types of possible recommendations. For example, that suppose I am trying to, I am expecting some recommendation when I am trying to go through purchasing something on Myntra or somewhere. So what should be recommended to me, would it be also similar to what would be recommended to you? And like any other recommender systems, we know that it all depends on that whatever items I have purchased or I have liked or I have given good ratings. Okay, so other people who have also given similar ratings, the items that they have purchased or interacted with, I am shown those ones, okay, as my possible recommendations. So standards of collaborative filtering, etc. But is it really what you need when you are talking about, say, fashion? Okay? That somebody else did something, whether I should also be recommended the same things. Okay? This is something that is not so easy to define. Okay? So whatever is recommended to me may not be something that would be recommended to you. Okay? So also that it's not only about, if you have gone through, I mean, if you have carefully listened to the slides that Chelaya painstakingly prepared and presented, is that there is something about color, etc., but it's not that only because somebody had liked it, why that person had liked it, we do not know. Whether it was because of the color or the checks or the material or maybe the cut, that is not so easy to capture. So it's not like capturing just the review of or the rating of a book. Okay? So there are so many other things which might be latent, and also what can happen is that it's not easy to capture that. So if I have to say that I like this dress because of these reasons, because this is good, that is good, it will be too much to expect from the user to actually enter, which is very difficult. And also, of course, that this saying that, okay, that you eat to please yourself, but dress as not to displease others. Okay? So, but that may not be true, right? I might like to wear what I am comfortable with, just like I would like to eat what I like. Similarly, I might not really care what others are thinking. So though there is a saying like this, but you may beg to differ from there. Okay, good. So let us try to see what people have done so far in this field in terms of recommendation. Okay, I'll have a brief idea. So there is a paper in SA Multimedia in 2012, quite some time back, so which says, "Hi, Magic Closet, tell me what to wear." So I'm going for a party or I'm going to attend a conference. I don't know how many of you did that before coming to the conference you had to decide, oh, this is something that I would like to wear for the conference, but if I go for a party, I would like to wear something else. But there is a paper like this which tries to get something which would let someone get a suggestion that, okay, you are going for this occasion, so you better wear this kind of dresses. But that too is not easy, we'll come to that. So this is something that about street fashion. I'll go into some more details in this, that of course that we talked about the fashion runways, etc., in the morning, but how many of us would really be comfortable dressing like those people which were shown in those slides in the morning? Might not be. So we are most of us are more comfortable with what goes on in the streets, right? So there is some focus on that. And there are these image-based recommendations on styles and substitutes. So something that is very important is that, suppose I have purchased a particular trousers and a particular shirt, and next time I am trying to do online shopping, what should be recommended to me? Say more shirts similar to what I have already purchased, or shirts that are different, because I may not, for example, I definitely would not like to buy the same shirt once again, and may not be even a similar, quote unquote, similar shirt, because I already have a shirt like this. Okay, I may want to have something different, right? So you don't know what, I might also want that, oh, that looked nice, so I would like to buy another one which is something similar but not exactly the same. Okay, you don't know what's there in the user's mind. Okay, so that would be a complementary. So we have like this, that I can either buy this shirt or this shirt. Okay, so this could be substituted for the other one, or I already have a shirt, I would like to buy a matching pair of trousers. Okay, so that is a complementary purchase that you want to do. So whether you want to substitute or you want to have a complementary dress. So basically there are these approaches of collaborative fashion recommendation, like collaborative filtering, some more aspects to it, some more complexity, and I'll add to that in the next slide. And there are this paper, of course, is also very important because, or interesting, because it says it is not just the color or the texture or the cut. So aesthetically it should be pleasing, and that can vary from one person to another. Okay, so how you can capture the sense of whether it's aesthetically pleasing, and then they use some kind of brain-inspired deep networks, okay, to capture the aesthetics, which goes beyond capturing the basic RGB colors or the basic texture, which are all low-level image features. And then there are, of course, some more papers on clothing recommendation on multiple image attributes, and more and more. So there is something that I'll talk about this in a bit more detail. I'll come to that. And these second and third papers are basically from Vikash's group. We discussed about those. So again, aesthetic based. And this is something very interesting that deepware, so which they are using deep learning techniques to come up with new designs, and then they have actually interacted with the tailors who would cut the cloth and actually make the dress according to what has been specified by the deep learning method, and then they try to see how popular that becomes. So this is our paper from our group. I'll discuss about this in more detail. So if we group them, the existing work, okay, so we can group them based on the flavor of the problem, that whether it is for individual recommendation, they take into consideration the effect it would have on different individuals, or it is just a common recommendation. So different papers try to address this problem, this point. Now, it's very important that, okay, be it style, be it fashion, then what is there in my mind? Is it that I would like to look like the others are doing? Should I follow somebody else's style? Should I go with the current fashion? Or I would like to look different? So it's important to understand that the requirement of the user could vary based on his own personal taste. I am quite aware that this is how the current trend is going, but I don't want to follow the trend. Okay. So whether I want to follow the trend or I would not like to follow the trend, the system as such a priori would not know. So if it keeps on recommending garments which are following the trend, I may not be happy. Okay. And then there is something about image generation I'll talk about. Then there are fashion ensembles, and then taking care of the aesthetics. So these are some way of grouping it, and whether it is only basic color, texture, features, etc., low-level features, and whether it is for special occasion or streetwear. And there is something interesting that whether it's for everyday use or it is for special occasion, that is this point. And the last point is that it is, even if it is for everyday use, there is a temporal aspect. It's not only, as was already discussed about the trend changing, it is that even during winter I would like to wear certain types of dress. Okay, I might want to wear more like dirt colored dress, and in the summer, in 2-3 months, I might like to wear light colored dress. Okay, and for the same occasion. So that is about with the season, things can vary, and even time of the day, whether it's during the morning or during the afternoon or during the evening. So it may depend on that as well. And the tools that have been used, that of course all the names that we keep on hearing in the conference every day, that standard techniques of machine learning and deep learning, these have been used. So we'll talk about some of them, how they are being used. So the challenges here are that everybody has his or her own personal perception of fashion. So how we can capture that? So if you tell the user to give a lot of data, the user will not be very happy. So how much of that can be actually extracted based on the way the user is interacting with the system? That will be interesting. But of course, that may lead to many false positives also. We have to be careful about that. So as is mentioned already, that how would the individual want to look like? Okay. So the other point is very important. It's good to keep recommending things, but is there a budget that the user has? When you talk about online recommendation, so I might simply recommend something, but which is too expensive for the user to buy. So that recommendation will be a waste. Okay. So is there a budget that the user has? So that is very important for online shopping. But if so, then you have to not only get it from the user, you have to also show that there are different alternatives, and then there is, of course, as researchers would like to pose that as optimization problems, show them to be NP hard, and then try to give some solutions. So those things will come into play. So also what is important is that, is it that you only recommend one single item or an outfit? Outfit is basically a combination of something you wear. So we'll go into the details of it, like top and then the trousers and the shoes like this. So that together form an outfit. And then what is that we are trying to optimize? And the cold start problem, of course, is always there, that there are new garments that are there in the online shopping, but there is no recommendation yet. So how you ensure that they keep showing up? Okay. And there could be so many others you can always contribute to this list. So at the end, we can think about that. So we'll talk about a couple of this. This is our work, our PhD student Devopriyo's work published in PKDD, and then briefly into the second work. So let us go to the first work in a bit more detail. So this is title is One for the Road, recommending male street attire. So there are a few things which are important. As I said, that we are interested in street attire. So what normally would people wear on the street? Okay, so that means that the data set that will be used also have to be captured from images which are captured from the street. It's not simply those ones you get from the fashion magazines and all that. Okay, so of course the general belief is that women are going to dominate the fashion world. Gen Y male, it's said that they are also highly fashion conscious, like we see here. And so that has actually become a major part of the fashion industry now. And then what's important is that there should be some efficient recommendation systems. So this is an overview that we have our outfit. So for each outfit, there are certain attribute values, and from there we predict whether this is going to look attractive if we wear it. And then if it is not attractive, then can it be recommended that, okay, if this shirt, this trouser, and this shoe combination is not going to make you look attractive, then which of those I can change so that it becomes a situation where you would look attractive. Okay? So we have done like this, and I will explain how it works. So we captured a lot of data. We had a total of 800 plus images, and of course those are cropped, and we did some pixelation to hide the facial features which might affect a user's decision whether to tag, as we'll come to, an image as attractive looking or not. So those some initial pre-processing steps were followed, and then these are the different standard terms that we'll be using. One is a torso base, so that is like a t-shirt that you wear, and that is TB1. Torso base 1, then torso base 2, which is a shirt that you wear on top of it, and then a torso cover, which is the jacket, and then we have this, the leg that could be trouser or the shorts or something, and then the foot F, which could be boots or sandals or slippers or moccasins, whatever. So these are the terms that we follow, and then in the survey, so we carry out two surveys. In one, each outfit was tagged either as attractive or unattractive, and out of those 824 images that we had, so this was the distribution. And in the second survey, what we did was that we asked the user to categorize whether this particular outfit that the person is wearing, whether it looks like it is conformative, it is individualistic, or it is an average. So conformative means what others are wearing, is it like that, or is it individualistic, or it's somewhere in between. So there is this quick demo. So this is the first survey actually that was carried out. So the users were shown these slides with maybe some four such images here, and then the user will have to click which ones are showing as attractive. Okay, so don't bother about this. So it will show that the user will decide which ones among these four is showing is attractive. So it could be one or more, okay, and then click next and next and next. So you can actually go up to 10 such slides in one session, so that what we get is that we get a ground truth about which of these outfits are looking attractive. Of course, it can be possible that in one slide I have marked, say, one image as attractive, some others not, and somebody else has done the other way. So of course we do some majority voting, etc., and then decide that which ones among these are really attractive and which are not. Okay. And then there were a lot of features to choose from. So based on what was the material and what was the color and things like that, the cut. So starting with some 33 categorical and 11 binary attributes, we ended up with 25 predictor variables. And we used a couple of standard ML tools to do the prediction. And once that was done, then our model was ready for the recommendation. So what we did was that now the user had to interact with the system about the kind of outfit that the user has, and then based on the prediction model, the system would determine whether that is going to make the person look attractive or not. If not, okay, then it will recommend a set of possible outfits by changing one or two of the components. Okay. So okay, so I think it will start. So what it means is that suppose I have this kind of outfit, so I mentioned these are the ones I have, and then the system says no, it does not look attractive. So if you change this, say the torso cover from this to something else, it will look attractive. Okay? Or it might say that if you change this shoe and the torso base one, then it will make you look attractive. Okay? So these are the possibilities that one has, and what we did was that we, sorry. Okay, good. Yeah, so it will give a recommendation that you change this to this, and that will be a better combination. Okay. Of course, that if I give one only option, then the users may not like it or may not be within budget for the user. So we can give 3, 5, 7 such recommendations, and whether that actually works, we check back with the prediction model. Okay. So that is the idea. Okay. So this is the name that we gave, that maloutrec is that male outfit recommendation, and then we evaluated it with our data set, okay, of unattractive outfits. Okay. And we had like this, say if we take a look at this example, so we had this sort of initial outfit, as you can see that we have a foot, then torso base 1, torso base 2, leg and torso cover, and then that as per the data that was captured, that did not look attractive. So it was replaced by a recommendation in which this was the modified outfit, and so I think it may not be still visible yet for the torso base 1, and that is what shows up as the recommendation. And we did a lot of experiments, and one of the standard one was a hit rate at k, means that if there is one recommendation or multiple recommendations, then how many of that actually make it look attractive. So and that checking was done by the prediction model. Okay, so I'll just go to the next work in short, just about 3 slides. That this work also I found to be interesting, because what it did was that it does a fashion recommendation and as well as a design. So what it does is that we are having a recommender system similar to what I talked about. Of course, it works in a different way, and it uses Siamese networks to generate different types of outfits. And also with that, it has a GAN attached, which would let the system come up with new designs, which is shown in the bottom portion, that personalized fashion design, that if that user wants that I would like to have a purple dress of different types, then that GAN model would be able to generate the dress for the user and show it up as possible recommendations, and which is a big step, because then that can be actually taken up by the manufacturers to come up with dresses if those really appear to be the ones which are giving good results. So this is the recommendation part, and of course that, as we know that GAN, one component is trained to generate the images, and the other component is used to distinguish whether the generated images are really looking completely out of place or they have some distribution similar to those which are there in real images. And it's important that the new images are generated which have distribution similar to the database images, but of course they are able to capture the requirement for the given by the user. So they used Amazon data set as well as some data crawled from tradec.com. So these are some of the examples that some generated images and L1 nearest neighbor. So it was shown that the generated images they had very similar type of look as compared to what was there in the database already. And these are some more examples of that. So that what they showed is that if you look at the top row, say top 3 results from data set, which is already there, real data set, and top 3 results from GAN, and the claim is that they look quite similar. So there are some values about the similarity mentioned below. So that was an interesting work because it went one step forward as compared to only giving recommendations. Good. So at this stage, what are the things to think about? So the application domain, so who gets benefited? Is it that the online retailers are getting benefited, the user is getting benefited, it's a win-win situation, and of course that there could be some hidden agenda also, that I could always first things that the items which are not selling, okay, I could make recommendations so that as if those are the ones that are matching. So there should be some actually independent way of checking whether the results indeed are correct and truthful. Okay. And also how to specify the input. So is it that the user would require to give lot of things as input, only then the system would work, or much of it can be actually extracted by the way the user is interacting with the system. Similarly, how do you get as the output? That is it just an outfit, multiple outfits, fitting a budget? So those are very important things to consider. And usability and flexibility. So how usable is it? And how flexible in the sense that how would it be able to cater to the needs of different types of people, those who want to be conformative, those who want to be individualistic. So those are the important things that are to be considered when you are thinking of defining your problem and coming up with the solution, and how level of personalization you can achieve, that how it would make sure that what I get is not a run-of-the-mill solution and not everybody gets it. And as I said, that started with Gen Y. Of course, we started with, I don't know, Gen A, B with Charles Dickens, okay? Then we talked about Gen Y and Gen Z people, of course, what they need, because Gen Y, most of you were around. So if you are into research in this field, you have to think of what Gen Z people would be interested in, because those are the people who, before they learned calculus, they learned deep learning, and before they learned how to use Cal-C, they learned how to use Keras. So you just have to be a little bit more careful if you want to jump into this field of research. Okay, you cannot go by what you think. You have to estimate what those people are going to think when they are going to. I mean, already possibly they are choosing what to wear and what to buy. Maybe the credit cards are still with their parents, but in a few years they will be actually handling the credit cards. So you have to be a bit careful. Okay, good. So we are at the end of our talk. So of course, it's, as you have seen, that the work has been ongoing for not many years. Okay, it's not just a couple of years, maybe about 5 years that things have been started. So you are all in the right time, so you can definitely join. And of course, being in Swiss Hotel, being in Bern, so you are heartily welcome to join the research effort. Thank you. Yeah, we'd like to take questions.
Hello. Let's thank our speakers once more, and we have time for a few questions. So please go ahead. You can raise your hand if you have a question. Okay, maybe they are a little bit embarrassed about their style and fashion. Both our speakers will be available outside during the coffee break, and I have a couple of questions. So for the style generation kind of domain, right? So how do you take into account the whole outfit generation versus individual pieces of clothing, and whether you can actually uh, so that is part one. Part two is let's say I like a suit or I like a certain outfit, but I want to make some changes. So could you take that into account and maybe send it back to a designer, kind of thing?
Yeah, actually there are two aspects to it. Style, but he can also add. So one thing, as I said, that getting the input from the user should be very in a friendly way. So as was mentioned in some of his slides, that one is that given an outfit, like or say given an image of, and it was also shown in today's morning session, that given an image of a person wearing, say maybe three pieces like torso, base, and then leg and foot. So there is some image processing work to actually take out the leg part and foot and the upper body. So there is a dependency on that. So if we only specify one part of the dress, okay, and we are not bothered about how it is matching with the others, given an image, then it is a simple problem or a simpler problem. But if not, then either the user will have to give us input that okay, I have a blue shirt and whatever, and then this type of trousers and this type of shoes, as in which might not be so easy to capture. So capturing an outfit might be a little more difficult unless we have a good automated tool for segmentation. And generally, if you see that coming from a background, that segmentation of natural scenes is not an easy problem. Though people are working for years, even if I just take people from the street, take images, segmentation is not going to give very accurate results. So it might not be always required to get accurate results, because it's okay if I get an idea about the color and the texture and things like that, it's fine. But there are some papers which talk about the kind of color you are having. Getting that in an automated way might be difficult. So I mean, outfit would be a little bit more difficult. Individual dressing.
Okay, maybe one more question then. If one goes to Myntra and I'm just shopping for apparel, then so there are already lots of style and fit related categories, like maybe regular fit or V-neck, let's say, for certain kinds of apparels. So those already, so those phrases already invoke a sense of how you could visualize oneself. Is it possible to use that information as part of the generative process, or whether you've tried looking at that?
Go ahead.
Yeah. So honestly, I have not looked at Myntra yet, because still Aruna is here, like from Myntra. But a short answer to your question is, even Flipkart has some of these tags and attributes. So today it looks like there's a lot more manual effort to annotate, and even from the designer or seller's perspective, rather than a lot of automation which has happened. But of course, we need to leverage that, whatever is out there for recommendation. But the harder problem is to looking at the textual description and the images without much cues about style. Maybe just based on the attributes, you need to decipher this kind of information. I think there's a lot of work which needs to be done.
Thanks. Before we let you go, so a small token of appreciation from our side.
Welcome everyone, and welcome to the panel discussion on challenges in developing and deploying AI ML solutions at scale in the industry. In this session, we will discuss all the real-world issues and challenges faced by AI ML practitioners in developing and deploying AI solutions or machine learning solutions in the real world for actual industry use cases. We have an eminent set of panelists, so I will try to keep my own comments to a minimum and leave the floor to them. During this course of this next 90 minutes, we will discuss the impact of topics like lack of data, noisy data, lofty expectations, speed and scale of deployments, annotations, cost of development, talent and skill availability, and all these other interesting things. For the purposes of this discussion, broadly speaking, AI is the application of machine learning, deep learning, NLP, image, speech, video processing, all the usual stuff you would think about. Okay, so if needed, take a broader view. The plan for the next 90 minutes is as following. I will introduce each of these panelists and hand it over to them to take 3 to 5 minutes to describe what does AI mean in your context for your organization, and what are some of both the success stories, lessons learned you see in how commercial deployments or production deployments of AI have gone from your perspective. And then I will ask some questions, and then we'll throw it open to the audience. Anything that's on your mind, you can go ahead. Okay? So without further ado, let me introduce the panelists. First of all, let me introduce Subhajit Sanyal. He is a senior manager of machine learning at Amazon. Subhajit obtained his PhD in computer science from IIT Delhi. After that, he spent 6 years at Yahoo as part of Yahoo Labs. There he worked on various problems pertaining to multimedia search, Yahoo Shopping, and Yahoo News. After the stint at Yahoo, Subhajit joined American Express Big Data Labs. There he worked on a variety of projects, starting from building scalable ML tools to extracting intelligent signals from transactions data to aid performance marketing initiatives. He joined the ML group of Amazon in April 2016. As senior manager in the India Machine Learning Group, he leads a team of scientists and engineers, and his responsibilities include building an ML platform, improving relevance and targeting of sponsored product advertisements, developing ML solutions, and all kinds of other wonderful things. So without further ado, Subhajit, please share your thoughts.
Hello. So good afternoon, and welcome back after the break. Let me tell you a little bit about quickly what does AI mean for me personally, and where I use it every day. I'll talk more about where we use it every day. So at Amazon, we're in the business of selling products, and we are selling these to customers who are the most important entities for us, and we want to sell the right products to the right person and basically satisfy their needs. And obviously, it's not hard to guess that almost everything there has some element of AI in it and some element of machine learning that goes on behind the scenes. Every time you go to Amazon, and till the point you make a purchase, until it reaches your home. So, just to give you some of the projects I'm involved in, and our team in India we are working on. So, we are looking at where do we start? So, let's. One of the core assets of Amazon is its catalog of products, and in the catalog, and it has billions of products, and it's very important to keep that catalog of products, the information in the catalog of products. So we want to keep it as clean and as hygienic as possible. So by this I mean that we have products which, so for every product we have a lot of information. We have, let's say, the name of the product, the price, the color, and the size, the weight, and maybe the images. Now, there are a lot of problems that can creep in. There might be inconsistencies that come in. So let's say that name of the product says it's a 40-inch television, but if you read in the description, it says it's a 60-inch television. So how, in a catalog of such billions of products, how do you figure out such inconsistencies? That's an ML problem. That's something we try to solve. We build specific models to detect such data integrity issues, and so that's on the catalog side. Then there are problems we work on in the ad side. So we do show you sponsored products ads. So what is the right set of, so the ranking problem, how do we rank those ads, and what are the right set of ads to show you the relevance of those ads to the query that you may have fired. So those are the standard ML problems that we look at. There are some non-standard problems we work on as well. For example, I was telling some of my friends, this is a recent problem that I enjoyed working on, is packaging. So, where at the warehouse we package all the products that you've ordered to be shipped to you. And these packages can be of different types. Some of them are cardboard packages, some of them are, polythene bags. Now, it is an AI problem to decide what is the right packaging for a product. It is an AI problem because, you want to optimize certain things. You want to optimize the cost that is involved in packaging, the material cost, the shipment cost. And at the same time, we don't want to incur damages. So, how do you predict whether if I change this cardboard box to a polythene, this product is likely to be damaged? So, so that's an AI problem. So that's an interesting problem, and that's something we got to recently. Then there are other problems around some kind of extreme cold start forecasting problems, where for brand new products which are just being introduced, which hasn't been in the market at all, how do you forecast the demand of such products? That's another class of problems that I work on. And then there are, again, something which me and my colleague, their erstwhile colleague at Amex, Aruna, I think we both work on this problem. It is this product designs. So, there's a lot of information that is there in the reviews and ratings and the question answers that we have about what should be the right product, what should be the right frying pan, what makes a good frying pan. And from there we can glean that information and curate that to create, a fantastic frying pan at this point should have these qualities that can help design a frying pan. So that's one aspect we are looking at. And then there are, so I think that's roughly a fairly broad spectrum of things we are looking at,
Thank you, Subhajit. Next, I would like to introduce Krishnamurti Vaidyanathan. He goes by KV. KV is the managing director with Goldman Sachs and globally leads the engineering associated with monitoring and managing Goldman's runtime applications and infrastructure. Additionally, he also co-heads Goldman's platform engineering functions in India. As part of his work at Goldman, KV oversees the application of machine learning to solve IT operations and service management use cases, more commonly referred to in the industry as AI ops. Prior to Goldman Sachs, KV has held senior roles with Depository Trust and Clearing Corporation, DTCC, Unilever, EasyLink, and Lloyds Finance. Welcome, KV, and your thoughts, please.
Yeah, sure. Can you guys hear me okay? So welcome to Zahra. I think it's been a good break. I'll try to share over the next 3 to 5 minutes, trying to touch on some of the topics that Nanda had mentioned in terms of the kinds of use cases we work on. But also, what are some of the challenges that we face as well? Yeah, so Goldman Sachs, for those who may not know, is kind of an outlier here, right? So you don't see many banks here other than maybe Amex being referred to over here. But why are we here? So we deal, like you have many companies over here that talk about, like Amazon deals with the movement of products, right? You have Myntra that deals in the movement of like goods, like fashion goods. We deal in the movement of capital or money. Right, so you could be gone are those days when you actually buy 1 share of Microsoft or 10 shares of Microsoft. There are firms that do that. We typically try to make money in dealing with maybe 1 million shares of Microsoft that are booked within a couple of seconds, and we make the money on the differential between the buy and the sell. Right, that's called high frequency trading. Now, when you have businesses like these, and you also have totally sort of diagonally different businesses like our wealth management business, where a celebrity, maybe a Hollywood celebrity, needs to manage their funds. So you may be asking the question, like, why does machine learning figure in any of this? Okay, it actually figures pretty deeply, because if you look at financial services in Wall Street, quantitative modeling started in the 80s. Like what used to be called, like we may not have called it data science back then or artificial intelligence back then, but quantitative modeling, use of math and use of statistics to basically determine what is the next security or what is the next stock that I should invest in. How should I manage the risk of the money that I have, and so on and so forth? Like, should I, like Bill Gates, invest money in this product, right? Because I have a lot of wealth, I'm becoming philanthropic, I want to make sure that my money grows and it's safe, it's protected, right? All of that is like very important consideration. So we use machine learning in a wide variety of use cases. Now, very specifically focusing on AI ops. What is AI ops? So if you think about like Goldman's sort of runtime, we have like thousands of applications that are serving different parts of our business. And each of these applications are hosted on like public cloud, private cloud, infrastructure, databases, servers, networks, and so on and so forth. So at any point in time, if any of this goes south, any of this starts not working as expected, our customers have problems, they lose money, we lose money. So in some ways, it's about like how do we make sure that we can be like precogs. If you've watched the precog movie, which one was it? Exactly, Minority. So like it's like Minority Report talks about precogs. Like, can you get ahead of the problem by saying that you will have a problem at 2:55 p.m. this afternoon because your network will run out of bandwidth? So forecasting is actually a very interesting use case. Short-term forecasting, longer-range forecasts are a very interesting use case. Anomaly detection is a very interesting use case. By looking at like thousands of data points of telemetry, we collect like over 70 billion telemetry events, like sensory information of how applications work, how infrastructure works. What's the CPU on a machine? What's the latency on a network switch? And all of this information is flowing in real time. Now, when you talk about applying machine learning in the real world, here you're trying to make a machine that's trying to make decisions. That's trying to make decisions in real time based on training data, based on the model that has been trained in the past. And when I say the past is a few hours old or a day old at the most, meaning our models are trained every day. Our models, every day is a new model. We test for model decay. We have safety switches, circuit breakers that switch over to a prior model if the model doesn't work. Now let me describe a very interesting problem. So I described this sort of complex nature of applications and infrastructure that serve all of these financial services businesses. Now, at any point in time, if there is a failure and a failure is reported to someone who's sort of looking at an issue ticket, and he or she needs to resolve this problem within seconds, how do you make that happen? Now, very, very common in typical microservices architecture, you have a lot of shared components. A shared component like a database or a Hadoop ecosystem, a node in the cluster fails. You have several thousands of these notifications going out to different teams saying that, hey, something in your sort of application ecosystem is broken. But how do you sort of correlate this? So what do? We take our corpus of logs. We train our corpus of logs on a log cluster algorithm. It is, it's based on some paper research that was presented in 2015, but also very customized for our purposes. And we are able to basically say, based on all the log lines in all of the different places, saying that all of these different problems that symptomatically look different and are being surfaced through sort of notifications or alerts to different people, or all have the same root cause. They're all because of this common service that failed or this common database that failed. It gets better. You not only detect the fact that you can cluster these problems together, and instead of sending them out as millions of notifications, hundreds of notifications, sending them out as one notification saying they're all related. So you're actually informing the business people that, hey, you know what, you just need to solve this one problem, and all of this thing that appears symptomatic goes away, right? Not only that, we actually classify it to say, is it noise or is it actually a real problem? What did people do in the past when they got this? Maybe that database has a problem, but maybe it's like an archive. Maybe it fails, and it's kind of okay in real-time processing to not have the archive, and you can sort of catch up later. Because why? Because seconds is what we have to resolve problems. If not, we lose money. So that in a nutshell is what I would say is a very successful problem case, one of our many successful problem cases that we solved. What's the hardest thing, hardest challenge? The hardest challenge has nothing to do with science. It has to do with getting non-data scientists convinced that this is not hocus pocus. We've literally had prediction systems that we did a bake-off with humans, and we had humans make the predictions, and we had the machines make the predictions, and we said, all you have to do is outrun the next person so not to be eaten by the tiger. Right? If a tiger is chasing you, if you don't want to be eaten, just outrun the next person. Who's the next person? Is the human. Your accuracy has to be better than the human. So we did a bake-off, and we had to literally prove that machine learning models are not like this crystal ball that are going to give you a result and you need to believe it in. And the people on the line, after they see these results again and again and again, and it's better than what they would have, they start to believe it. So those challenges continue to exist.
Thank you, KV. Next, I would like... Can you hear me? Hello. Yeah. Okay. Next, I would like to introduce Dr. Aruna Rajan. Aruna is the Senior Director of Data Sciences at Myntra, where her team works on building intelligent software in trends detection and forecasting, fashion retail planning, and computer vision based question answering systems in fashion to address similarity, completing a look, and other interesting fashion applications. Aruna has a PhD in theoretical physics from UIUC and has spent a very long time in academia doing fundamental physics research between BITS Pilani, TIFR, Princeton, and UIUC, acquiring both perspective and experience. She began her career in the industry at IBM Research and later worked at American Express, Flipkart, dabbled in her own startup and Target before joining Myntra. And Aruna is a former colleague, and it's a pleasure to have you.
Yeah.
Why don't you share your thoughts?
I think I have something in common with all of you. I've worked with nearly all of you, and I worked in investment banking for a while and ran away from it. It was too hard for me. Millions of dollars in a couple of seconds. Yeah, it was scary. So this topic of AI is kind of very pertinent to me. I graduated in theory physics. I know that's hard to imagine and kind of sad, but I made it through. And one of the things that we didn't used to call what we did, although it had a lot of data involved, was AI, and we didn't call it data science. And the term was new to me as I entered the industry. I think it was not very popular then. It just kicked off in the last 10 years or so. So I've watched this transition from in myself from a scientist to a very reluctant industry practitioner to a very full-scale person in the industry who's dealing with engineering problems such as scaling and systems breaking, logging, and things like that. And so this topic of what makes AI hard to implement is kind of very close to me. I'll try to summarize what we do in Myntra in about 3 minutes. Broadly, we deal with all kinds of problems that Shubhajit mentioned, because we're also a retail company. We retail in fashion though, fashion merchandise only. So we have the same cataloging, search, recommendations, and all of the data quality issues that a large retailer, an internet retailer, would have in retail. Additionally, what makes data sciences at Myntra, and especially what we work on, interesting is that we do data sciences that's kind of specific to the problem space of fashion. I think Vikas also works on similar things at IBM. We work on 3 large areas. One is planning for fashion, and planning for fashion is kind of special because every season we wear different clothes, and it turns out that every season retailers make different clothes, and about 70 to 80% of what a retailer makes is wasted. On an average, it never sees a customer. And next season, they again make clothes, right? So a season is, by the Europe cycle, it's every 6 months, and sometimes every 4 or 5 months. And now there are fast fashion companies like Zara that make dresses and make clothes for women every 45 days. So you can imagine how often do we have to get it right, and how much are we wasting and kind of piling up the oceans and the landfills with things that you don't wear. So please buy more. But that aside, we work on forecasting problems. We work on assortment planning problems in the retail space. We also work on counterfactual frameworks, like what happens if you sell a cheap-looking blue T-shirt at 200 rupees while Adidas releases their new blue T-shirt at 2,000 rupees on an offer, right? It's generally maybe 20,000, it's now 2,000, what's going to happen? So these kind of scenarios, scenario planning and counterfactual frameworks. We also do fashion design intelligence, which kind of, I would say, sets us apart. We look for trends, we forecast trends, and that's based on what you all are wearing and posting on Instagram and making public, what are celebrities wearing, what are influencers in fashion wearing. We also do something very special where we look at generating fashion. And the idea there was, to stretch the limits of AI. And I know that, we had this question of what is AI, and everybody addressed that. It so turns out in retail that we call any computer program that makes a decision AI, right? And that's very relieving because, then you can do all kinds of AI. But moving on from AI where, it's obvious that a computer can beat a human being, and maybe in situations like which KV mentioned where they've proven again and again, for example, in high frequency trading, that algorithms can beat human thinking. there are areas in which human beings have, some superior intellect, like creativity, like design. So the idea was, can a computer even poorly mimic what a human being can do in design and making clothes? So again, we've trained a bunch of networks to kind of replicate images of fashion design. We do generative models to come up with new and quirky fashion design. So can you combine elements of what is Egyptian and what is Indian and come up with some new quirky design that a human designer cannot think of, right? So this was the challenge that we took up, and we have a brand, Moda Rapido, where we put out computer-generated merchandise every month. It's a small fraction of the merchandise, but we still do that. So this is briefly, the whole spectrum of how we take AI to production, from search recommendations and returns prediction, fraud prediction, to demand forecasting, to actual fashion making, which I consider more of the AI of trying to mimic human beings, is the large spectrum of what we do.
Okay, thank you, Aruna. So next, I would like to introduce Vikas Raikar, another former colleague. You met Vikas in the morning, and he gave an excellent talk. He works as a senior researcher at IBM Research. He's an expert in machine learning and is currently focusing on building machines that can understand natural language and images on par with humans. He finished his doctorate from University of Maryland College Park. He's also defining a roadmap of what can be done for fashion and retail industry, primarily leveraging deep image and text understanding together with other AI capabilities. Welcome, Vikas.
Thanks, Nanda. Yeah, so I work as a researcher in IBM Research. So I think IBM Research is a little bit of a strange place to be in, because it's at one end it's sort of research, but at the same time we don't call ourselves research. We have to make an impact. We have to make something for the product. We work with clients. So I think what has been for the past 6 years, I've been with IBM Research. I got a chance to wear all different hats possible, right? So the first 3 years, I was completely focused on there are these something called the grand challenge projects, where you're completely heads down in building something like a Jeopardy, or probably we worked on something called as a project debater, which was designed to build a system that can debate with humans, right? And that was a very different experience. There's no an immediate delivery, but this is something no one has done before. You're kind of heads down and trying to build it up, and for 3 years, and then after 3 years you sort of get bored, and then you decide, okay, what am I doing? And then sort of you get, okay, maybe let me want to do some client projects, right? And that's where you get some experience where, of course, still IBM works. I mean, that's a little bit of surprising that why IBM and fashion. I mean, we started off this as a small, incubated this as a small project for what we call as AI for fashion. But probably within 6 months down into the project, I realized that IBM has something to do with every major fashion brand out there in the world, right? And traditionally, they have been doing a lot of, they're maintaining their IT systems, everything, but now they why not IBM does all the AI for them, right? So in the IBM AI for the research project, I would say there are 2 different hats. So one is what we call as, we build these very core APIs, fashion APIs, right? Which is, given any fashion image, parse it. Tell me whether it is a shirt, what is the t-shirt, what kind of t-shirt, what is the color, what is the neckline, what is the sleeve length, is it a shoe, what kind of shoe, etc., right? So parse any fashion image, give detailed attributes, and so this pipeline is kind of an ever-evolving pipeline, and for this you need to have a little bit of more research scientist heart, right? So essentially I need to read up papers, see what is the state of the art, try to keep pushing the accuracy as much as possible, right? And deployment, production, that's all taken care of, but the only challenge there is to make things as accurate as possible. And the second hat you have to wear is now, okay, so you build this APIs, what you call as AI-based APIs, and you want to build solutions and people come and talk to you, and that's where you go into a little bit more of a builder mode, right? And this is more of, you think of the data scientist mode, where you work with the client, they give you data, you are trying to build models for them, and you want to quickly deploy them in production. And typically this can be roughly around a 2 to 3 months kind of a pipeline, where you start the engagement and then immediately you have to deploy it on the cloud and it has to scale up. And so this is probably one of the hardest part, because you're always working with inaccurate models, we're working with messy data. And here the hat I try to wear, the mindset I have is research does not matter, data scientist does not matter. You think of more of as a carpenter, right? You're building something, and that's where you experience matter on what is your tool chest, right? How quickly can you at least, I mean, there are tons of tools out there, but how many tools you are good at, right? So essentially, you kind of build your tool chest, you sharpen your tools, and can you build something quickly in 2 months and then build to production, right? So that's roughly my three kind of hats I wear at IBM Research. One is like this pure core researchy hat. Then there are these kind of API improvement hats where you're trying to push the accuracy of the core AI tasks. And the third is kind of quickly build something which works well in practice and deploy it into production, yeah? So in the past life before joining IBM, I also had this experience on the other side, which is a little bit scarier, was in medical imaging, where we're trying to build these models where, for example, we had this digital mammogram scans, and you're trying to build models which can predict particular region in a CT scan or a mammogram, is this malignant or not, right? And this is, again, the hat is a different. You're trying to, so we kind of work on 2 to 3 years continuously to push the model accuracy, because all these models have to go through an kind of an FDA approval. So they're extremely strict requirements, and every time you get a new data. So if it does not fall off, you are happy, right? So essentially maintaining the accuracy was important, and that was kind of another different experience, yeah? And so my one suggestion in all of this is essentially what I realized is that though the domains are very different, it always helps to think of kind of having the persona in mind. Who are you designing it for, right? For example, if you're in the medical domain, it's something for a person who is going to a CT scan. And there, the false positives are extremely important, because anytime you misdiagnose it, the doctor has to actually, by law, has to order your biopsy. And biopsy is an extremely painful process, right? Any FP you make essentially has an impact, and that's where the FPs are important. Maybe in fashion, it's a very serendipity. False positives are not important, because you always want to sell something. Maybe it's okay, accuracy is not important, because what does it matter? Maybe you discovered something which was wrong, but maybe that was probably more interesting than what you're looking for, right? And that's where the whole accuracy game completely shifts, right? So in each of this, I think I kind of start with the persona, whom are you designing it for, and then take the routes can be very different, yeah?
Thank you, Vikas. And next, I would like to introduce Dr. Vishwa Vinay. Vishwa Vinay is a research scientist at Adobe. He holds a PhD in computer science from University College London. He spent 8 years in the information retrieval group at Microsoft Research in Cambridge, working on enterprise search and recommendations, web crawling, and related areas. After a couple of years at American Express, where he worked on statistical models for merchant servicing, he joined Adobe in December 2016, where he is working on search-related problems and assistant technologies for digital marketing. Welcome, Vishwa.
Hi, everyone. So I'll just start with stating that my working definition of AI is that it equals machine learning. So I know Russell and Novick's textbook. I studied it at university, but didn't necessarily use the content in that in any great depth. And I know there's a new wave of AI, but it's all kind of new tricks for an old dog. So I haven't really sharpened my tools, to use your phrase, with them yet. So I'm at Adobe, as Nanda says, and Adobe's tagline, which you'd know if you dropped by our booth, is make experiences that matter. And the definition of experience here is where end user interacts with content created by a brand. And Adobe's interest in this is in the entire spectrum, from the creation of the content all the way through measuring how people are interacting with the content, so that it can feed back into how better and more engaging content can be created, where better is defined in lots of different ways, including aesthetics, design choices, as well as just popularity. So that's kind of Adobe's sort of interest in the area. I also want to kind of highlight I would say 3 themes that I represent on the panel today, and potentially represent me as an industrial computer scientist. The first of that is kind of career trajectory. Soon after I graduated with a PhD, I joined as a postdoc. And about midway through the postdoc, I had to convince people to try and have the word applied in my job title, because I thought that reflected better what I did. Today, pretty much everything people do is kind of applied machine learning of some flavor. Newer job titles have sort of been invented to describe various flavors, whereas the truth of the matter is, has just been pointed out, we've all sort of done everything along the spectrum at different points in our career anyway. So that kind of historical perspective of how the companies that I was part of evolved, as well as the field itself evolved. I kind of have some sort of view of that. The second thing is I've always worked in a kind of horizontal research group, which is a sort of a shared resource for the whole company, which brings in kind of very different types of challenges. Firstly, you have to interact with various people within the company who are your source of problems. And as a scientist, it's your job to try to find the commonalities across those problems and abstract and go and solve those abstractions, because that's how you provide value. And once the problem is solved, then you have to go shopping around and sell your solution to these consuming parties. So working in this kind of a horizontal group rather than someone who's tied to a narrower business problem, that sort of represents my history. And the last thing is, most of my career I've spent on enterprise problems, which means my employer had customers, and the data was created by my customers' customers. And the products or services that my employer wants to put out, the ones in which we want machine learning, needs to consume this sort of data generated in this two-hop sense. So it's sort of slightly different, if you like, from the vanilla versions of Amazon or Myntra that we know of. So that brings in additional challenges of safely using this data and how do you generalize across these different customers and so on. So yeah, I just want to point out those. If you hear me saying anything, it can probably be attributed to one of these three axes. So that's me.
Thank you, Vishwa. And just a few words about myself. Several of you may not know me. I'm Nanda Kambhatla. I'm the Vice President for Enterprise AI at Symphony AI. Symphony AI is the largest and fastest growing AI startup in the world. We are building transformational companies, enterprise software products in various verticals like healthcare, retail, finance, HR, media, and so on. Previously, I spent many years at IBM Research. I came out of it as a distinguished engineer and master inventor. And I had the pleasure of working with some other people on the stage here. So without further ado, let's get right into it, right? So the first question I have for the panel is, AI the answer for everything? Like, you know, we all work in various businesses and industries in different domains. AI is the hot thing. Some product manager or a senior executive comes and says, you have to use AI. Okay, is it the solution to everything? And a corollary is deep learning the solution to all the problems in the world? Who wants to take?
Am I the answer for everything? So let me take the deep learning part then, you know. Is deep learning the answer for everything? That's because, you know, AI, yeah. Deep learning, so personally I feel there are, you know, I have come across certain classes of problems where maybe deep learning may not be the right thing. And again, there are, I can think of two considerations. One is maybe the compute cost. That's a practical consideration. So you burn a lot of hardware, and you need state-of-the-art GPU resources to train good deep learning models with a lot of data. And many times you may not have that much amount of money to do. So you might have to resort to more practical and more tangible methods. That's one. And on the in a more another type of problems that another reason why I have seen is, let's say, where you want to do some kind of a let's say a causal inference, or you want to have a more explainable model. So there are works in deep learning where people are trying to improve the explainability of the models and the decisions and interpretability of the decisions. But let's say you want your model's predictions to be interpretable. Often you might want to stick to families of models which are easier to interpret, and it is required at times. We come from many of us come from a banking, background where, let's say, credit decisions, they better be interpretable. I won't give you a certain credit line. There should be a reason, because you might sue me, and I can't tell you, this network, this, unit fired somewhere over there. I can't just tell you that. That doesn't make sense. I have to tell you, we did not give you this credit line because your CIBIL score is below this, or something like that. So, and often making these kind of interpretations are not very straightforward in a deep learned model, and also more around causal modeling. Although there are some works around, I think recent works by Bly et al., deep probabilistic programming and all, but I haven't read about those. But to build a causal modeling framework with, it's hard to do. I'm not very aware of that. So that might be some area. So apart from that, small data, it's not a big problem in my mind. You can get around with, by doing some pre-training with some huge amounts of data in another context. So, yeah. Anybody wants to add?
Go ahead.
I suppose returning to your question, is AI the answer to everything? No, but hopefully there's a large enough pool of things until I retire that keeps us sort of busy and well paid. But one of your sort of trainings as a scientist is sort of how to frame the question correctly and identifying an interesting question. And if you come in with your bias of the toolbox of tricks that you bring, then part of a good problem definition is finding one for which AI is the answer, right? So I suppose that's the bias that we will bring, that inevitably we have all worked mostly on things for which AI is the answer. And I'm sure there are lots more, because we have tons of colleagues who don't do AI. That's a reducing number, but they exist. So these problems also are plenty.
Yeah, the question sort of reminds me of back in the 90s. People software developers who worked on databases used to believe that everything in the world can be solved with stored procedures, right? Almost any problem in the world could be solved with stored procedures. I don't know if you guys, this is sort of a little dated kind of an example, but to me, you don't want to be a hammer looking for a nail. So it's important, I surround myself with data scientists and software engineers. I run an engineering organization. So my perspective is that try to understand the problem first, like what is the business problem that you're trying to solve, and is a probabilistic answer, the right answer for it. Because if it's a problem that can be solved deterministically, then that's probably the better way to do that. When you don't need to introduce probability, don't introduce probability to it, right? But on the other hand, if the problem does merit it. So let me give you an example. Let's say if the decision was, should I open you up for a surgery? Would any one of you want to go to a hospital that relies completely on an AI model that determines whether I should open you up for a surgery? Probably not, right? So the answer may also be somewhere in between. Maybe the AI model gives, like you said, like detection of, you have this type of a disease, and then it's a surgeon who makes the decision. So maybe it's augmentation, right? So the decision lies somewhere in between, but I think the key thing that I would say is that the understanding of the problem first to determine whether or not you want to leverage any form of those data sciences per the definition that Nanda described. Or for that matter, I see a lot of hype around deep learning, like almost every problem that I want to solve is because of deep learning, because it's like looks really good on the resume. But maybe you don't need deep learning. Maybe linear regression will do, right? You're trying to classify, maybe a linear regression will do.
So I promised Shubhajit and KV earlier that I will try and differ from them to make this panel discussion interesting. And I think panel discussions are these reliefs after day-longs of very important and interesting work that you come and want to look at a big boss-like setting with people arguing with each other. So I'll try to entertain you. So I kind of agree that a scientist must come in with a problem and not with a toolkit. But just in the interest of keeping my job, and not just keeping my job, but kind of growing my job so that I take over the world, and so do all of you. The way I look at this is that reframe the question as, is there an answer to a problem? If there is, then put it in the ambit of AI, right? And I think that is the way AI has kind of grown, because when I was doing my PhD, neural networks were not called AI. And now pretty much everybody who says AI is referring to deep learning or neural networks. And when I started working, logistic regression was just like something where you, instead of fitting a straight line, you fit a sigmoid, and that's okay, that it's just stuff that you do every day in your, maybe in your 11th or 12th for fitting, things that you measure of a lab instrument. But, and then we decided that all of this is AI, and this makes us special, so this makes us employable. So I just want to add a business perspective to this. So this question is relevant because a lot of business people look at, on a daily basis, we get questions like, what does data science really do, and why do you need data science? Maybe I don't need AI in my organization. So I want to kind of argue that you do, because everything that you can do today, AI can do, and it's kind of, it's a loop, because anything that you do, I will call AI, and I will do it better. And I think the idea, and it's not so far-fetched, the basic idea is that any business runs on a certain kind of thinking. So if you are able to pose questions in the business more scientifically, if you're able to frame your questions such that the answers need more and more complication to compute, then maybe you are making a big difference to the business. And I think internet retail is one such area where AI is pretty much bread and butter. You do need computer scientists who can code for scale. You need computer scientists who can do logistic regression as well as as well as run data through CNNs, and all of this becomes bread and butter as in when the Amazons, Alibabas, the Flipkart, and the Mintras keep catching up with the latest. This becomes what every developer must do. So, in a sense, if AI were to be all pervasive, then I would argue that yes, we could do everything. I mean, if there is a business and it's running, then I'm pretty sure that AI will do it better.
Okay, thank you, Aruna. So Aruna feels that AI can answer the meaning of life as long as it's 42, there somewhere.
42.
Right. 42 is the answer. And so paraphrasing KV, perhaps one of the interesting challenges we all, I'm sure, have dealt with is how do we translate some business requirements to what is the technical solution, which often might involve AI and sometimes might not, and but that translation is very important rather than go around with the hammer that where is the nail, then how do we really architect a solution to solve the real business need rather than say where is the next LSTM that you're training. So I want to move on. I was reading a tweet by Andrew Ng today morning, right? He was saying that, and this paraphrases a discussion we were having yesterday over dinner. He was saying that in software engineering, you have a lot of traditional processes that have now standard practice. Things like version control, code review, agile coding, bug tracking, etc., etc., etc. In the new world, where machine learning is no longer some exploratory thing in labs around the world, it's being deployed in practice. Hopefully, you saw many use cases for real-world business applications. What are the tools, processes, methodologies for AI deployments in production? For example, just as an example, what is the equivalent of version control for models? How would you decide which model to deploy, or how to keep track of all the hundreds of things somebody may be experimenting on? Your thoughts and best practices. Maybe we'll start with you, KV.
Yeah, I mean, see, we were having this discussion last night about the analogy to a software development lifecycle for AI, right? And there's some very interesting considerations there, right? Like I described, in our case, models are trained every day and the model changes every day. So in a traditional organization, they would say, where's your change ticket? What am I going to do? Code the model to also put in an automated change ticket that I'm changing? That doesn't quite work, right? What's a version of a model? Maybe I can have the version of the Python code and say, that Python code is changing, but how do I actually handle model versions? The other thing is that if the model is replacing human decisions or augmenting human decisions, now there are implications, like in the business that I come from, it's highly regulated. So a human making a bad decision has regulatory implications. A model making a bad decision, what implications does that have? Do you put the model in jail? Do you penalize the model? Or do you penalize the person who wrote the model? What if the person who wrote the model wrote it based on a paper that was presented here? Do you penalize that person? Like, I think the considerations around both the ethical aspects of it, the control aspects of it, the SDLC aspects of it, are not that well invested in the industry. Now, every firm, like IBM has its own, like, sort of philosophy around how it manages it. I'm sure Amazon does and every other firm does, we do as well. But I think one area that almost seems like if somebody's looking for a startup idea is like, who could be the next Git lab? Who could be the next Git lab for model development, right? So I think there are some considerations to be thought about there, including things like, how do you create like monitor for model decay and trip models, right? Should that just be part of like standard software practices, right? So,
Any other thoughts? Anyone wants to chime in?
Probably I'll, So probably I'll go ahead. At Amazon, we have spent, at least I have spent a fair bit of time addressing some of these questions. So one of the hats that I wear is I'm in charge of building a platform for machine learning, which is targeted towards making lives of scientists easier in terms of experimenting with data, building models, and at the same time making the transition to production from that experimental code, making it seamless and easy. And it's different from what you see from the public offering of Amazon, the AWS. It's an internal thing that we built for internal Amazon use cases. And it's focused on, so there, we have been focusing on different things. So what we have realized is, and I'll just touch upon some of them. So when scientists experiment, we want to give them the complete freedom. So we don't want to constrain them that, okay, you have to write your code exactly like this. Otherwise we won't accept it in production. They should have the complete freedom. But having said that, once they have written a piece of code and they come to you and they say, okay, now go ahead and productionize it, it becomes a nightmare. So there, what we try to do is we try to go ahead and see what are the different what we can call as boilerplate stuff that the scientist keeps on doing again and again. So a huge chunk of it might be loading data from different repositories and transforming them in a certain way. So can we provide them ready-made constructs which are completely unit tested and integration tested and everything, which have with all the proper controls of software development? Can we give them constructs which does it for them? And so they have the data ready. And all they need to do is write only this essential bit of code which plays with the data, trains a model or scores the model, and that's about it. So we try to reduce we look at the boilerplate stuff and try to harden it with proper code and build frameworks for that. That's one aspect. Then one important thing which you talked about is model monitoring, for example, when a model goes to production. So we have frameworks in place which tracks a model's performance over time. Not only the model's performance, we look at the data distribution changes over time, the data that goes into the model. So we'll try to look at distribution changes, so that is the data drastically different from what the model was seeing before, and we have triggers and alarms which will prompt you to maybe retrain or trigger an automatic retrain cycle, and you need to set up all of this properly. And then we also track the predictions over time. The prediction distributions, are they different? Is the model predicting most of the scores are in a certain range? So those kind of things we have for model tracking, and they're absolutely necessary to make a practical production system. Then another important aspect is obviously the version control. That's a beast. I don't know what is a good answer to that. What is a good versioning of models, ML models? What is a good unit testing or integration testing of ML models? That itself is not very clear to me. Those are things, as you said, the next Git for ML models will be a fantastic thing. But now with there's a huge popularity of all these notebooks and all. I believe something might come from that side. And the notebooks are becoming which is becoming the bread and butter tool for scientists, all these, Jupyter and Zeppelin and others. So they are becoming increasingly popular, and they are coming in with some kind of version control of the notebooks itself. And yeah, so that's some interesting play might come from there.
Thank you, Subhajit. Go ahead, Vikas.
I think I'll just add, I'll just stress a little bit on the data aspect of it, because this was some experience we had in Siemens and everything, which is, I mean, this doesn't relate to like keeping track of what data you use, but kind of putting constraints on how much data you can use, right? It's extremely easy for us to overfit on data, right? So at least in the scientific community, it's where people report p-values, it's known that the moment you use your test set once, it's already corrupted, right? So anything inference you draw, you're already fitting a model in your head and trying to kind of fine tune to it, right? So kind of when I was working in Siemens, we had this kind of a data lock policy, right? So there is sort of a training data which you're kind of free to use, do whatever you want. And there is sort of a validation set which you use to use the report kind of thing. And maybe after 6 months, there is some data which is completely locked up, even we can't see it. There's some guy who just runs the accuracy report on that and just gives you either thumbs up or thumbs down, right? He doesn't even tell you the number, what is the accuracy. Okay, this is good or bad, right? And then you go back, right? So the more you hide the data, the more constraints you create, I think your less chance of overfitting and the better the models become over time. Yeah.
Actually, just on the data side, a small interesting thing that happens in large organizations, so which you must be aware of and which you should be aware of and be careful about. So this happened in our place, in our team, in fact. So, and I'll explain what happened with maybe not go into the exact details. So what happened is we have various predictive models around products. So there was one model that was predicting, let's say the demand for a product. It was forecasting the demand for a product. It was using a certain set of features. And there was a table that was populated with the predicted demand for the next week and all. Then there was another model that was predicting returns for a product, and it is a certain set of features, and it was using, this I'll just simplify it a little bit. So it was using the predicted demand as one of the features. And it so happened that the predicted demand model was using the predicted returns as one of the features. It wasn't just a simple, single connection. It was a deeper connection across multiple models. And people never realized, because these were disparate teams who were building different models. And we just realized that, okay, hey, we completed a loop. Okay, this guy is predicting something which you're using to predict something else, which you're using to predict something else. And that is all feeding back. And it's an unintentional EM loop. You don't want something like this. So, data lineage is an important thing. And that's a very important thing in a large organization. So to maintain where this data came from, where and how it is used. Yeah.
The one thing I'd also add to that is traditionally when you design software and let's say you're in a sort of microservices like architecture, and you say, okay, fine, has the service been tested before it's been rolled out, right? Okay, fine, you can have a set of regression tests that sort of tests with the thing. Now when you talk about versioning and you talk about testing, it's actually very interesting in the model, sort of the ecosystem of machine learning models. What version of your model have I tested with? That, because we're not there yet completely today, in my view, like just talking to people where you have there are several firms that use ensemble of models, where models calling models in like 3 or 4 or 5 or 6 levels of separation. But we're truly not like standard software where the interconnections between services in a microservice architecture could be so nested. We're not there yet. But guess what? When we do get to that point, how do you handle testing? Right? So I think there are more questions than answers.
I agree. And even the question of if you're, let's say, deploying a chatbot or some in a real production setting where millions of end users are using it, and you are doing a daily release. Is today's version better than yesterday's in a quantitative, rigorous production way? And what is your operational model for deploying a new version up there, right? And there might be various AI ops, as you were mentioning, as a evolution of the DevOps in the AI world might be very much needed. And I think I want to touch on something several of you mentioned about data, right? That's a flip side. It's not just models. And at least from my experience in the commercial development of AI systems, almost any of them, the vast majority of the time, I would guess as much as maybe even 60-70% of the time is, and you can all disagree with me, is spent on gathering the data, cleaning it up, curating it, annotating it, do endless iterative cycles of these. So any thoughts on what would be needed to progress that field? And I'll just make one observation, right? How many talks have you all heard over the last few days on different AI models, and versus how many talks on data curation or data engineering or on data massaging, which where bulk of the time is spent in? Anyone?
I'll start. So maybe the starting point is the sort of comparison with more traditional software engineering. So I suppose the first step is the acknowledging the distinction between code and data, right? So you fixed a bug in a feature. Is that a new feature now, or is that the old feature? So now you've got code and data, and now you introduce a new concept of a model. Some computation paradigms will decide that model and data are roughly the same thing. How do you label an algorithm, right? The algorithm takes data as input and produces a model. Through an experiment, right? Now you've got one batch cycle of a train validate test. That's one notion of experiment, but that's not the way. The world isn't there today, right? The world is far ahead in sort of continuous experimentation and things like this. So, and one final sort of complication in this step is, as I said, working on enterprise products. If you build a machine learning model, if you build a machine learning product, you put it out there, and kind of data scientists in your customer's company go through these life cycle. How do you support them, right? So again, yeah, more questions and answers. And as with the traditional software engineering field, I think it's all TBD there. So it's likely even more TBD here.
Okay, I want to move on to another topic, which I think Vikas touched on. So there's a question to you, Vikas. There's the importance of the user experience of an AI application, the persona of who is using it, right? Let's say, an accuracy of any business user will say higher the better. Why not get 95%? It's unacceptable for you to have 95%. Is 95% or 100% sufficient to deploy an AI system, or on the conversely, is some 60% accuracy means you cannot deploy it, or is accuracy itself needs to be in the context of some user and what they're trying to accomplish? Maybe because you can.
Yeah, I think that's a good point. I think probably will never be a system which is 100% accurate, right? I mean, with all the progress so far, if you look at ImageNet, the top one accuracy, I think, is still 80%, right? So that would mean what? 1 in every 5 images you get it wrong, right? And now you're talking about putting something in production where 1 in 5 images you see gets mislabeled, right? So that's why I think we tend to get a little bit creative on what are the metrics, and again, that's almost in the context of a persona, right? So I don't know if people are familiar with design thinking, or at least in IBM we follow that, is we always start with the persona in mind. Who am I designing this for, right? Who is the end user? But sometimes it depends on the end user. For a fashion, maybe the accuracy does not matter, because, the end user is okay, it's always trying to buy things more, right? We kind of had, sometimes I think, for example, recently we had worked with something like a GANs to generate automatic kind of prints, right? And here I thought that was a failure because the model never converged. It was not getting with accurate metrics in terms of the GANs, whatever. But anyway, I thought, okay, let's anyway fly it with the designer. And in fact, what happened was that the designer actually liked the prints from the GAN better because they were sort of abstract. They didn't capture the finer details. And he thought that's probably more interesting for him than if you accurately recreate the actual image, right? So again, what we thought was a kind of a bug, or could even be a feature if you think about whom are we designing it in the mind, right? And again, the medical example I gave you, where false positives really matter much, right? Because if anytime you make a false, it's okay if you don't detect a cancer, because what happens is eventually the cancer grows a little bit big and doctors can always find it, right? Because the kind of the malignancy, it starts with a small tumor, it grows up big. If you don't detect it very early, after maybe next year it will grow up big and you do it, but the cost of detecting it falsely is there's a liability on the doctor. So there's a lot of agony for a person to go through an actual biopsy, right? So that's kind of my take on it. I mean, there's no right or wrong answer for this. It's all use case dependent. You always have to think who is going to be the end user for your system, and it all depends on that.
Thank you.
Yeah, I would like to again touch upon a couple of things here, mostly for the benefit of some of your students here and would be joining the industry soon. So in an industry, you're actually not training a model, you're solving a business problem. That's the first thing you have to remember. So, and solving a business problem doesn't stop at just training the model and handing over that logistic regression or maybe CNN LSTM ensemble. So it doesn't stop at that. So to give you an example, we were working on this problem of detecting products with incorrect metadata, and we realized that okay, we'll build a model which will detect inaccuracies in the metadata, and we could hit a certain percentage, and when you and at a very high percentage obviously our recall, a very high percentage of accuracy, our recall went down, so we were catching very few of those. So at a high percentage, we said, okay, so now, but we have to solve this problem. Somehow we cannot show products with, incorrect metadata to our users. So how do you solve the problem? You just can't say that, okay, take a cutoff at this percentage and, block all these guys. But what are the others that happens? So there what you do is you say, okay, you have to then sit back and work with the business team and figure out what are the other avenues in which, so maybe at a high percentage cutoff, you block off all those products and say that we won't show them. Maybe at a slightly lower percentage, you suppress them in search results, So in the sense that you demote them. So they're still there, they're not blocked, but they're unlikely you will find them. So you'll have to come up with a mix and match of techniques and to solve the problem. So it's more important than achieving a certain accuracy. You have to solve the problem. That's the most important thing. And secondly, the other important thing that you will face is even after having deployed your model, you'll have to keep on constantly measuring the effect that your model has. Maybe let's say you have to keep on monitoring how many defective products you are ending up showing in the search results. You have to do that, because what will happen is every now and then some senior executive will come, hey, yesterday I fired this query and I saw that, I saw this one. This is a bad, there'll be an escalation like that. And then what do you do? Like for every escalation, you can't just go back and tweak your model. So if you are monitoring the health of your search results and you have a ready number that, okay, even last week, the number of defective images in the top 100 was X. And this week also the percentage of defective images is X. It hasn't deviated from that. This is a one-off case. At least, you don't have to, run after every escalation. So that's an important practical practice, So, yeah.
Thank you.
So in my perspective, I think the accuracy of models is a factor of tolerance. So tolerance as in the tolerance of the business that you're in, tolerance of the individual or the group of individuals whose decisions you're replacing or augmenting. So it's a factor of tolerance. Now, why do I say that? If a model, if let's say going back to the medical example and you're about to open somebody up for surgery, one may expect that, that if you're influencing the doctor's decision, then the accuracy better be good, like it be reasonably good. Now, what is reasonably good? That again depends on the tolerance of the doctor to say whether he's using that as one of the many factors in making the decision, or is he giving like 80% of the weightage of the decision to that model. So the aspect of tolerance plays very well. Now, you also look at like certain industries, like I won't name them, but like where you upload photos and they classify the wrong individual as the wrong like kind of thing. We've seen several incidents around that. That can like tarnish the reputation of firms. So again, what is the tolerance of that particular business or company in being able to accept lower accuracy? So I think accuracy is very subjective to tolerance.
Right.
Can I? You want to go? So I was just going to say, people I've worked with will sort of realize I'm a stuck record on this particular topic, but I think what in machine learning would be design of a loss function. That's incredibly important. I'll give the example from search, which is the domain I'm kind of most familiar with. So whether you're Myntra or Amazon, if you are in charge of search there, then as a business, they care most about making more money, right? That's at the end of the day, that's the game. They ask you to improve search, so you define a proxy metric, I don't know, mean reciprocal rank or NDCG or some such. And you can see there is a gap between NDCG or whatever your chosen metric is and the business metric. And then you've got something you train your machine learning model on, cross-entropy or something. And now you optimize on cross-entropy to make it as high as possible, and you're surprised if it doesn't make you more money. I think there's something broken here. And I think part of where the with the maturation of tooling, where we're going, it's extremely easy to write down models, right? It's just so simple to declare the model structure. And then if you do have the data, then inference is extremely easy. Everyone uses Adam with learning rate to the -3 and whatever else, right? So in some sense, the one place where, as a machine learning scientist, where your sort of input is most valuable is in designing what that model is going to now optimize. And that's a skill I think we should ensure that as practitioners in this domain we kind of have. And the curiosity to operate in that entire space, right? Like understand the business problem, find the closest metric, find the closest approximation that is optimizable, and then go and optimize that. So yeah, I'd say sort of focusing on some notion of accuracy anywhere, any one place in this stack wouldn't be good, but sort of realizing that the best place would be where there are no gaps between elements in the stack. I think that's where we need to be at.
Thanks. Aruna, you wanted to say something?
Sure. I thought I'd add one more example and kind of talk about how businesses stress on accuracy, and I also wanted to touch upon how AI could be the answer to everything. Just kidding, but so there are some, everything that everyone here described is true of things that I have seen as well. And even at Myntra and Flipkart group, we often have models with interdependencies that we are not tracking, and that leads to, accuracy degradation. Sometimes the accuracies go up crazily, but let me give you a real example of, let's say, predicting returns, right? So in every e-commerce company, you all shop because you can return if it doesn't fit you, if you don't like it. And there are many millions of you shopping at any instance, and especially during large shopping sales, there's a lot of returns. You often change your mind. There's something selling on Amazon and something on Flipkart and Myntra and a bunch of other places, and you have to decide which ones to keep. And sometimes you like something and your spouse doesn't, and so on, and you end up canceling, right? So this is very hard to manually look through and guess. Should I dispatch a packet that someone has ordered, or should I wait because this person is likely to change their mind, right? And going by the answer of does this need AI, when people would have said maybe not, this is something that, it's the human mind, you really cannot predict it, and so on and so forth. But the same was kind of true of stocks. So people do predict stock movement. So we do have models that predict the likelihood that you are going to cancel something or return something, right? And now the question is, how accurate does this have to be? And this is this is not as important as a surgery or something that's going to kill you, but it's very important. Your competitor might kill you if you don't get this right? So a lot of business managers and product managers would tell you that if your model for returns is not 95 or 99% accurate, then you cannot deploy it, right? And so again, I would argue that it would be much better if that person were conversant in ML. So therefore, practitioners of AI should do everything. So the answer is you don't have to be 95% certain that somebody is returning something. If you're maybe 60% certain, you can do a different thing. If you're only 40% certain, you could do a different thing. So some of the things that we do to kind of check whether you're going to return is sometimes people pressure you into keeping the thing, like send you a message saying, hey, you got this wonderful t-shirt, this was worn by Pariniti Chopra the other day, I'm sure you like it, and then maybe change the likelihood that you're going to return it, right? There are things that you can do that way. You don't really have to delay dispatching the t-shirt. So if you broaden the spectrum of decisions that you will make based on a program, that I'm loosely calling AI, then your accuracies don't matter that much. It's a question of what are you going to do and how much certainty are you willing to attach to that. And the answer is always that these things can be, at least in my experience in the business,
42.
Yeah, is that, these boundaries can be pushed. And there was something that Vishwa mentioned on, knowing which metric to kind of optimize on, and at least in our industries, what should be done and how it should be measured is conventionally the role of a product manager. So now this has become a very gray area where everything is transitioning to ML models, and then there are people who are trained in business management and who now have to deal with uncertainty in decision making where the decision results from a program. And now this is a wholly new aspect of product management that people are not used to. They're used to decision making with uncertainties that humans are okay dealing with, not uncertainties produced by a program. So therefore, I will argue that those of you who do AI should go on and do product management, and and also do product management while you are doing your AI, and decide what metrics and how important are these metrics, how often do they need to be logged, monitored, and modified for your particular use case or your business problem.
Thank you. Completely echo the thoughts on product management. So here I just wanted to share a couple of thoughts on this accuracy thing and all, right? Exactly as some of you were pointing out, I think it's all relative to the utility you see with respect to the business situation you're solving of how it's currently done. And so in some cases, 60% accuracy might be very valuable because the current state is so bad, right, that this is moving the ball and there is some additional utility in deploying a model. In other cases, 95% may not be acceptable because you can't tolerate that 5% errors, and there might be life and death situations. So I guess it goes back to figuring out where that AI model sits in the larger ecosystem or the business use, and figuring out what is valuable there.
And again, I'll just be devil's advocate to something both of you said, where you talked about life and death. And I mean, we seem to have consensus here that whenever life and death is involved, don't rely on AI. I'll slightly differ, and not just for the sake of differing. There was recently this news on a Chinese university training a neural net, basically an AI system to clear the surgery exam, right? So now you can look at it two ways. Like that particular program passed the surgery test in China, which maybe is more rigorous than India or anywhere else, I don't know, but let's assume India. Then would you be happy to be operated by this machine? I mean, I would argue that if a machine can beat a doctor, then if you are okay being operated by a doctor that could have been beaten by a machine, you should be okay being operated by a machine as well. So in any cases where we often say that this is a question of life and death, and therefore I'm not comfortable with a computer program deciding it, I would say it's more of a philosophical, many times it is a philosophical hang-up, and if you really think about it, then whatever is making that decision might as well be a program, and it doesn't really change anything very much. Right. So I think I will look forward to that Chinese program operating me sometime.
Makes sense, touche. So I do want to, I'm mindful of the time, I do want to turn it over to the audience now. Anybody want to ask any questions to any of the panelists? Go ahead. Can someone help with the mic?
While we are at the question of life and death decisions, would you say, is it more the case of that we want to hold somebody responsible when there is a decision that when it is that important and we cannot hold models responsible, hence we don't want to do it? Or so that is question number A. And question number B is, Just to the point of models clearing surgery exams. So surgeons are not just objectively evaluated. They have, residencies where there are humans supervising, and that evaluation is has a lot of subjective elements. So I don't think anybody would be comfortable letting a surgeon who just cleared an exam on paper to operate. So what
This was actually not a paper exam. It was a proper, I think the program passed the whole surgery module. But I'm not trying to say that you should get operated by that program. I'm just saying
But
that.
there are other examples, right? Like we are all flown on planes completely driven by autopilot for 95% of the flights, and which is a life and death situation.
But I would argue that even when there are autopilots, there's a reason why there are still pilots in the cockpit, right? So again, I would say my view to your question is that, there's a lot of constraints. Again, I would frame it in the thing about tolerance, right? So clearly, maybe the government of China, I don't know if it's mainland China, Taiwan, or whatever, but the government of China and regulation there and laws there have a higher tolerance to people clearing surgical exams and through an AI bot. But maybe, the government of India would probably be comfortable with a surgical bot that assists in surgery sometime in the future, with a doctor being there, right? So again, I think it's a matter of tolerance. It's a matter of tolerance with respect to legality, with respect to regulation, with respect to the doctor who has to, at the end of the day, sign off, with respect to the FDA, as you pointed out. So.
Yeah, just to complete that on the medical aspect. So I have a bunch of friends in Bangalore who started a company, I think you also know, Sigtuple. So they are in the business of doing AI-based diagnostics. So that's one space where AI is heavily being used. So they want to shorten the time between you giving a blood sample and getting the results. So you give the blood sample and then you walk out with the results. They just want to give you that experience. And many of the tests can be done like that, through an AI. And then also in the drug design, that's another area where AI is heavily used. So yeah, we are putting, knowingly or unknowingly, we are putting our lives and health in the hands of AI increasingly.
So I'll just sort of play devil's advocate to what you said there. I mean, the first part I acknowledge that maybe we need somebody to blame, including God, so we, prefer it being a human being. But plenty of, if you think back and look at where all these reservations are coming from, I think most of us are trained to believe, rightly or wrongly, that human intelligence and the way we have kind of engineered society around measuring and benchmarking human intelligence is somehow the most superior. So you're fine if some surgeons watch the other surgeon performing surgery and clear him, just an example. But you're not fine if a computer program passes some objective criteria to do this, or maybe there are other computer programs measuring this computer program. So I would say this is a very philosophical point. There's no way to kind of convince you one way or the other, but what I wanted to say was none of these things are absolute. I mean, I think what you are not comfortable with today can become the norm tomorrow, and it's not unthinkable because it may not be true that we are the most intelligent that can operate on ourselves, or it may not even be true that we are intelligent at all. So,
yeah, I just want to just rephrase something you said, KV. Like I would say, instead of tolerance, I would use another word. Like it's really about, whether it's a human or a machine, you would expect rigorous testing and evaluation of the quality of the output or the process, right? And it's really about, are we moving the ball, adding value with the addition of technology? And if you are, I take your point. That it can, there's no reason it cannot, and we will probably see increasing uses.
To contradict myself. Contradictions. No. I have to, right? That's how you get to good decisions. So to sort of contradict myself, right? So so if you thought about like maybe 5-6 years back, and you said, would it be possible for a doctor sitting in Chennai to operate on a patient sitting in Nagaland? Like people would like probably the same reaction, right? Like I don't want to do that, like with my doctor sitting somewhere else and remotely operating on the surgery. Today that happens. That happens in India. So I think again, it's an aspect of, I'll continue to use the word tolerance, but social tolerance. It's like culturally, are people getting comfortable with it? Maybe someday in the future, maybe that'll happen. And our MBBS students will be like masters in medical sciences of AI medical sciences, right?
Any other questions? Yeah. Anush? Okay.
Okay, a simple question. Is the whole domain of data science stuck in a local extrema called as deep learning? If no, why? And if yes, what is the momentum that we can apply to push the data science out of deep learning?
Are we stuck in a local minima called deep learning? How do we move out of it?
Well, to give you a slightly different perspective, actually in deep learning, I was reading a paper where they say that, the local minima, the quality of the local minima is also important. Okay, so in fact, they claim that SGD gives you a local minima which is very flat compared to other types of local minima. So maybe this local minima is flat enough, and you're going to be stuck here for some time.
Sorry, go.
I have like a more practical take on this is, we don't have any other choices, right? Is, let's say, if, I kind of see if it is anything to deal with images or speech, it has to be either a CNN or an LSTM, unless you come up with a better thing, right? And anything which is kind of, let's say, tabular data, I don't think probably deep learning is the right, then you have either, let's say, a logistic regression or XGBoost. So I would say there are kind of 4 local minima, or this 4 things I kind of work with: CNN, LSTM, logistic regression, XGBoost, right? You can solve almost all the problems out there in the world right now. These 4 techniques, right? Any combination. And yeah. So anything, until someone pushes it out, it's a valid thing. But I think it's a good local minimum. Considered from the earlier kind of baselines we had, right? We are stuck in a better local minima than earlier.
So I'll just say that no, we are not stuck on deep learning or anything. It's just that sometimes you hear a lot of something because it's interesting and exciting and new to people. And when I was doing my PhD, I was actually very bothered that nothing that I was doing was real in any sense. Now I understand that it was real in many more senses than real is. But we used to think that what is the point of all of us sitting in a room and talking about renormalization group or quantum field theory, and what's the real deal? The real deal is in going and doing a surgery. But as it turns out, not all of us need to be that purposeful. I think talking about something very much creates a lot of cultural interest around it, and I think it's important that we create a lot of computational as well as cultural interest around deep learning. So I agree that the minima is at least attractive, if not flat, and let's dwell on it apart from other things. And when something culturally compelling comes up, we will shift to that.
Yeah, other question.
Good evening. So after working for last couple of years in AI and attending this conference, I have come to realize that there is a pattern that we look for an open problem statement, we work towards that, we make a model, we publish or we deploy. So moving as an extension to this, what are your thoughts on like general intelligence? An intelligence model which can solve maybe multiple problems which are not very closely related. There's work in NLP going on where we can do different languages together or different tasks at the same time, but overall, how far are we to model a human brain, basically?
How far are we to modeling artificial general intelligence?
Out of syllabus for me. It's too intelligent for me.
It's too general?
No, it's too intelligent.
No, I think we are quite too far, I don't claim, because I think what essentially we are building is a very focused machines, right? It's essentially to do one task well, right? Either predict this or drive there or something, right? So that's kind of, we don't have a sort of a plasticity which is essentially associated with the brain, right? Where we can learn new tasks, we can adapt things, and that's why I think the whole everyone has an intuition that, That's why you don't trust machines that much, right? So we have a little bit more, we are ethical human beings, we understand the consequences of our actions, we can do 10 different things, we have humor, we kind of factor everything and then kind of take a decision, and we are not actually that logical as machines, which I think is a good thing, right? And that's where I'm kind of, I don't think we are there yet. I probably, despite what the press says, will probably a very long way there, where we have sort of the so-called general intelligence in machines, right?
Yeah, but one important thing that I think we should all be cognizant about is ethics. So ML now gives us a lot of power, so gives governments a lot of power, and in being very intrusive to people's privacy, and so we should be very cognizant of that and be responsible on how we deploy ML and use ML.
Right. So my point of view on this, there are at least two ways to look at it, right? Are we trying to build some system that mimics the human brain, or are we taking inspiration from the human intelligence to create technology that will solve real world problems with the actual value? And I think there's without question, we are solving greater and greater challenges, and you saw a spectrum of these on the stage here, including surgery and all, right? Where AI and technology is helping. So as that progression continues, those questions will become more real, but at least I agree with Vikas that right now, I don't see it as just on the threshold of a general intelligence. I would, at least my preference would be to go deeper into solving more real world problems. Other questions? Yeah. Okay. I think I've been advised we need to cut it short. So why don't you give a big round of applause to all these panelists thank you so much for the discussion. Yeah. Okay. So as a token of our appreciation, let me hand over some moment to Subhajit. Vikas. KV. Aruna. Vishwa. Thank you so much. Thank you for your attention.